I'm very happy to introduce Bruno Kurtic, who is our founding Vice President for Product Management and Strategy. He was one of the first employees here at Sumo Logic and has tremendous experience in this domain. And really what Bruno is going to cover today is a lot of show and tell, a few slides, and then really digging into how the Sumo Logic service can use its search capabilities to troubleshoot and analyze all your machine data. And Bruno has been sort of instrumental in designing and creating the product along with our co-founders, Christian and Kumar. So with that being said, let me turn it over to Bruno to take the webinar away.
Great, thanks Sanjay. So like Sanjay said, welcome to the webinar. Really glad that you could join us for this deep dive. I've looked at the attendee list and it looks like we have people who have actually had hands-on experience with Sumo Logic and would like to maybe learn a little bit more about tips and tricks. And also we have people who probably have never interacted. So what I'm going to do is I'm going to talk through just a few slides to level set everybody, get everybody on the same page as much as possible, and then I'll talk a little bit about what I'm going to cover in the deep dive, and then we'll just go right into the demo and troubleshooting scenarios. So first of all, Sumo Logic is a cloud-based log management and analytics service. We collect infrastructure, IT data, machine data of all kinds, and we help our customers manage and analyze that data set to derive IT and business insights. So the core three use cases that we cover today are troubleshooting and forensics, which helps our customers identify incidents, find root causes of problems, and this is where we're going to spend most of the time today with our Search Deep Dive webinar. But we also cover a couple of other use cases, such as proactive monitoring. Most of our customers use Sumo Logic for both of these use cases. They first troubleshoot and very quickly identify issues, and then they can set up proactive monitoring to detect issues before they actually impact their infrastructure and their customers. And then finally, it's business insights. Because we deal with a lot of data from both IT infrastructure as well as applications, such as retail apps, software as a service applications, and general web apps, a lot of data that they generate contains a lot of really interesting business relevant information. So we have many customers who use Sumo Logic to put a real-time tap onto their business performance and monitor that and use it for real-time business decisions. So I'm going to go to the next slide now and show some of the common use cases and applications that people have deployed on top of Sumo Logic. So we have a lot of customers use us for analysis of web applications, like I said, SaaS, retail apps, sites, news sites. It's all in the purview of sort of web intelligence. We have a large chunk of our customers who use it for IT operations, who leverage Sumo Logic to manage, monitor, and troubleshoot their IT infrastructures, all the way from large server farms to networks to devices to so on and so forth. We have a lot of customers, actually a big chunk of our customers, probably the biggest one, use Sumo Logic for application management, for essentially making sure their core business applications that are customer-facing and internally-facing apps are up and running without trouble, that they're not experiencing downtime, and that it can resolve issues found in those applications very quickly. We have customers who use it for security and compliance to ensure and deliver on compliance regulation requirements such as PCI, FISMA, and various others. And then we've got a variety of vertical use cases with customers who send us all kinds of data that's of the similar structure that we have in general IT data, but has a different nature, and it comes from devices like industrial machinery and things like that. So those are the core use cases. I'm going to go now and switch to the next slide, where I'm going to show a little bit about, foreshadow what we're going to do in the deep dive. So we encourage our customers to look at their entire stack of data. We firmly believe that when you have an issue with your applications, on any layer of your application that issue can be caused by any layer in the stack. Sure, an exception in your app code or a bug in your code can bring down your application, but so can the open source component that's having an issue, so can the database problem that you have underneath the application, and going all the way down to virtualization and network. If you have a big distributed app and your network's down and those nodes can communicate, your application can be down as well. So without understanding the full stack of behavior, you will always have blind spots. So that's how we deploy our service with most of our customers. So when you look at this data here, you've got a lot of unstructured logs, and when you sort of look a little deeper, this is actually a sanitized failed transaction that I put together that has, all of these logs have timestamps. Those timestamps look different. From each log line, they're telling you the same thing, but they all look different. They all have, some of them have a time zone specified as like PST. Some of them actually have an offset time zone from GMT. Some of them don't have a time zone at all. Others have things like key value pairs, like a session ID up here, but that session, even though it appears in the next line, doesn't actually have the same key. And so basically this is the nature of this data set. It is not structured. You can't simply write a SQL query against it to figure out what's happening. And in this particular case, it's an example of a transaction or a set of transactions that's actually failed because deep down in the stack, the operating system ended up killing a process. And that process happened to be a database process that was serving up this application, and when the database went down, a variety of transactions that were experienced by customers or initiated by customers failed. So without really having the full stack of information, it would be very hard to figure out what the root cause of this failure is. And we're going to walk through some of these scenarios in the next few minutes. So what am I going to cover? So I'm going to cover a few techniques, such as search term isolation, being able to use Boolean Logic, wildcards, and metadata fields to narrow down what you're looking for. I'm going to cover some parsing. We have a variety of parsing capabilities in the product, and I want to show you what we've got available, and some of them are more useful for some scenarios, others for others, and we'll explore some of those. I'm going to show you some conditional logic, how we can actually trigger conditional logic in the code that's based on data. Then we're going to dive into aggregations, transposing data, time slicing, and sessionization. So these are all very important advanced techniques that help you analyze your data sets. And I'm going to use these techniques to try to accomplish the 4 scenarios on the right. Actually, we probably won't get through all 4, but we'll try. So the first one is going to be issue tracking and deep dive, essentially looking across your data, looking at what kind of problems you're finding. Then we're going to turn that same scenario into a monitor to make sure that we can analyze the data and actually view it in some sort of a dashboard so you can keep track of what's going on. Then we're going to work on measuring distributed transaction performance. This is a very common problem. I actually have a slide or 2 on this once we get to that scenario to set it up. Many of our customers have an issue with their applications in terms of measuring transactions. And then finally, if we get to it, I'll work on generating a performance histogram for all of the transactions that we can find in any particular time range. So those are the things that I'm going to cover. So I'm going to now switch to my browser and show you a demo in our product. So let me now share my browser. Okay. All right, it looks like it's showing up. So I'm going to log in to our one of our deployments. Just for context, this deployment that I'm logging into right now is a deployment that is an internal deployment that we run in our testing. So it's running new code. It's running on new code. It also consumes its own log. So this is a real scenario. I have not looked at this data. I don't have a whole lot of information on what's in these logs. So we're going to go find out what's happening in this particular deployment. I know that it usually, because it's non-production code, it's new stuff, it's got a lot of issues. what we collect in this deployment, this is running across some 30 or 40 nodes in the cloud. It collects data from all of our application modules, all of our application nodes. It collects data from operating system, from network, from the host intrusion detection systems that are running on our host and firewalls that are running on our host. So really contains the full stack of data like I described earlier. So what you do typically when you're sort of trying to figure out what's going on, you start pretty broad. So I'm going to start by looking for some terms here and seeing what we get as a result of the search. So I'm going to look for across the last hour of data, because that's when we experienced the issue, and I'll look across and look for things like errors, let's say, or exception, or failures. And so what I'm demonstrating here is that we can use Boolean logic to determine what terms we're looking across. We can also use wildcards that help you broaden out those terms. So for example, as you know, in a lot of Java stack traces, you see exception, like a null pointer exception as one word. So I'm using wildcards to make sure that I'm catching all of those types of exceptions as well. And word fail simply lends itself to fail, failed, failure, all kinds of things, and I want to make sure that I'm catching everything that's coming from this data set. So if I run this query, this is going to scrape the last hour of data across all of our nodes. So I didn't restrict this to any particular node, and look, lo and behold, I've got some stuff coming back, and it looks like actually pretty big data set in this case, 10,000 almost hits across this narrow data set. So let's look at this stuff and see what we see here. So on 651 pages of data, so that's not very helpful. I'm not going to navigate 651 pages. But if you look at here, so what we've captured here, that there is an exception, end of stream exception. Then as you sort of scroll through, then you've got some errors appearing, some failures down here, and so on. So basically, it looks like stuff's happening. It also looks like some stuff is actually not really that interesting, such as we've got levels of information that we log in Sumo Logic. So for example, this particular line here is an error, but it's actually an informational line. So I'm not sure that that's of interest to me. It's just basically, it happens to be a method called log.error. It's not an actual error, so maybe I want to exclude those. So let's actually try to figure out what kind of logging levels we have here to start. And so I'm going to use a field extraction operator. I'm going to show you 3 types of field extraction operators today. The first one I'm going to use is the regular expression extraction operator that's particularly useful for this particular thing. So I'm going to just say parse regex here, and what I'm going to do is I'm going to identify this logging level field, and I'm going to take a very simple regex here that I hope it will suffice. And essentially all I'm going to do is I'm going to say, if you see a plus or a minus, because the offset, we log with offset in time zone, so I know it can be a plus or a minus, so I want to make sure I catch everything, and then I have 4 digits. And then what I'm going to do is I'm going to name that field. I'm going to call that level. And I'm going to run that. So what I've got now is I am parsing, essentially I'm trying to parse this particular field here. So I am going to run this again, and basically what we're going to see is we're going to extract this level field here. Right, so now I get a little bit more of a picture of what's the data looking like across this data set. So I've got some info and warnings and errors, and again I've got too many data sets. So if I run this, if I want to sort of exclude some things, let me just see what the picture is. So what I can do now is I can do a quick aggregation on this field. I can do count by, and I'll do count by level. What that gives me is the information on how many actual messages I'm getting across these logging levels. And so, I can quickly get a sense of what that is, and it looks like actually more than half are really informational. And really, what I really probably care about is to observe what's happening within my warnings and my errors. So one of the things that I can do is I can actually now use the conditional operator and drop all of the unnecessary information, in this case info. And I'm going to use a simple where clause here, where I'll say, well, level is not info. If I run that, what that's going to do it's going to essentially rerun the same search, give me all the same information, and only give me warnings and errors and things that I might be interested in more than information. Like, for example, you know, if you scroll through this, you don't see any informational messages anymore. Okay, so all right, so we're getting something here. Now, let's go a little bit deeper. As I said earlier, I'm going to show you a few interesting ways of extracting data, right? Regular extraction is good when you have sort of convoluted, complex text that you want to parse out of. You know, this, what I parsed out here, you know, I had to anchor on an actual changing value and a pattern, so that's why I use regex. There are various other things that are, and then we end up having to default back to regex maybe 10% of the time, and we've improved our parsing operators to really help you get sort of the easier stuff out. So for example, if you look at these fields here, you see that we've got a bunch of fields. We've got a host field, we've got a module field, we've got a logger field, we've got a thread field, and all these things. So there are a couple of ways you can do this. One is you can use this to actually use our visual field parser, and you simply highlight what the part of the message you're interested in. You get a few options. If you select the parse, select the text, what you can do is you actually get this nice little pop-up that comes in. You said, okay, this is the value I want to get, and then I'm going to name that module, and that inserts in the appropriate place in the search the parse module command, essentially, that you run, and now I'm going to extract module out of every log line where that particular field appears, right? So now I've got two fields that I can look at, and let's look at this real quick, and we can do count by module just to see what is happening here, right? Okay? So now it looks like I've got, you know, a variety of modules here that are in play. It looks like stream is maybe the biggest issue. We're having most issues with stream. You can visualize this any way that you prefer. We've got a variety of types of graphs that you can use. I think for this particular thing, a pie chart is actually a pretty good type of graph. Okay, so parsing. Let me go back to parsing and show you yet another nifty little operator that you can use depending on what kind of data you have. So we have these automatic operators that can automatically extract fields and values, right? So a lot of people log in key value pair notation. As you can see, we do as well. A lot of people also log in other types of notation, such as JSON, right? JSON is a very common logging format, and so we have operators that will help you automatically extract fields out of key values and JSON type operators. So, for example, if I wanted to, for example, extract logger here, all I do is I say KV and I name the field, and our search language will automatically figure out where that field is, because it has the ability to detect key values in each message. And here we go. Now I've got a new field that is logger, and it extracts this text that basically we inject into our log messages to ensure that we tell the end user which actual facility logged this information on behalf of our application. Okay, so now we're in a place where we got some interesting data. It tells me, what this tells me is that I've got some stuff that's been going on over here, you know, in these sort of 4 or 5 minutes. Not really sure what that is. I mean, I can click around and sort of navigate, and it looks like I've got all kinds of things happening there, but I'm not really certain. It looks like this Avro thing is repetitive, but then I've got other things mixed in. So how do I really figure out what's happening? So one of the things I can do here, let's actually do a count by logger here, and show you another little nifty operator that can be very useful to eliminate information from the data set. So I'm going to turn this back into a table and look at, for example, here, I've got a lot of things. So let's say that, for example, we are not interested in showing some of these pieces of information. So let me just see what I could restrict here. So let's say that I'm not interested in anything that's an endpoint type of an issue. So let me just exclude the endpoint. So that'll exclude this one and maybe some other ones up here. So what I can do here in our where clause, in our where clause you can chain them. You can actually have multiple where clause statements in any log search. So here I can say and I'll say not, and you can use an exclamation point to describe that, and say logger matches star, and what do we say? We said endpoint star. So this is a very useful operator that essentially does a wildcard match against string. So it enables you to say, like, look, I don't want anything that looks like this particular field. I want it all excluded, and if you now look through this result here, you won't find anything that has an endpoint in it. Right? We support other operators, you know, with the matches and where clauses. We have an if operator that allows you to actually do if-then else statements. We also have an operator that is called the where-in, so you can provide a set. So one of the ways that I could have done the logging level is I could have basically said where level is in, and I would specify inclusive statements such as, you know, error or warn. In case you had 10 different logging levels and you only wanted to look at 2, the other way is better, which is you say, like, here's the set that I want to look at, and not this is the stuff that I don't want to look at, which is what I'm doing right now. So, okay? So now we've got some, again, we've restricted some things, we've narrowed it down to the terms we're looking for, and it gives us some information around, you know, I get a picture, but a good picture, this is a good picture of what's the snapshot of my last hour, right? It looks to me that, you know, I'm getting some util uncaught exception issues that I'm hitting. I'm having some arrow issues and some, you know, Hornet queue health check manager issues. But it doesn't really tell me what's happening right now and what's the distribution of these. I don't know what's driving it. I don't know if this particular spike here is driving, you know, all of these errors are happening in this one bar, or if they're happening across the board. So what I'm going to do now is I'm going to show you how to actually time slice this information and actually look at it on a time scale and tie the relevance of the actual data series to the time scale. So it's a very straightforward thing to do. So what I'm going to do is I'm going to create a new field, and that's a special field that we have. It's called time slice. So I'm going to insert a command here in the search at the beginning. I'm going to say time slice, and I'm going to look at this by 1-minute intervals. So all this is going to do is going to include this special field into each log line that I will be able to operate on as I want to later analyze this data. So, and instead of doing this, why don't we do the following? So I'm going to do the count by module. Actually, I'm going to do count by time slice first. What this gives me is something that's going to look very similar to what the histogram above is looking like, right? So you're seeing basically that I have manually recreated this histogram above. That's not very useful, but I can do a couple of other things that can make this much more useful. So here again, I'm seeing that we've got counts of issues that are pretty clustered. So now I can do is I can do this by count by module and time slice, which means it's going to create tuples, a row for each tuple of a module and a time slice, and that'll give me a little bit more information about what's actually going on. So what this is going to do, what this is actually doing right now, is it's showing me that as I look through these, each one of these is now a more specific spike. Right here I'm saying that, look, it looks like our module stream had a huge spike at 1041. So that gives me now that this particular spike is probably related to stream, but it isn't necessarily fully clear yet. So how can we do better than this? So let's actually, when you look at this in a tabular information, it's basically telling you that, you know, it's matching each time slice and each module, and it's giving you individual counts. But what I actually want is I want to actually create and transpose this data and make it, create a row. A row will be time slice, and a column will be module. So let's see what happens now. All right, so now I'm actually creating new data series out of these modules and their counts of errors by module. So if you look here, now this table looks a lot neater, and I can actually say, look at my ops module, and I go down the timeline, and I can see what's been happening, right? That's helpful. It could be probably more helpful. As you can see now, they're registering themselves as particular individual lines. So for example, I can turn things off, and that gives me a little bit more information about what's going on here. But there is yet another better way to do this. So if I actually just go and simply change a property of this chart, and I say I would like to stack these series, now we're getting into a place where we can start getting some context into what's actually happening, right? So as I suspected earlier, the spike in here actually was driven by only one issue. It's an isolated issue. It came from our stream module, and it is basically reflecting exactly what's happening here. And we've had spikes and issues in our stream module in other areas as well. So you can imagine having something like this in a dashboard, and this is a timeline, time scale information, as it scrolls from right to left, the newest data being out here on the right side. You can monitor how your application is behaving or how your infrastructure is behaving based on actually meaningful information to you. To us, a module is a very important piece of information because it is how we organize our code, and that tells me that we're having issues in this new code in our stream module, right? And of course, you can sort of drill down into these things. So if I turn off the stream module because it's sort of clubbing everything down because it's so overpopulating everything, I can then start looking across others, and it looks like I've isolated hotspots here. It looks like our CQ module and our raw modules have had some blips, but they usually don't appear. And it looks like that our config module is kind of harmonicking around. It looks like there's nothing, and then it spikes, and then there's nothing, and then it spikes. So it really just gives you a very good way of understanding what's going on in your infrastructure. So that's the first scenario, the sort of going from a very broad, looking at errors and exceptions, to really getting a good understanding of what's the behavior of your app across those important levels of logging that indicate errors and failures, right? Okay? So I'm going to stop there, and I'm going to actually switch the screen and show you, set up the scenario for the next specific use case. So I'm going to share the PowerPoint again. All right, looks like that's working. Okay, so I'm going to go now. We've done the first two scenarios. We're going to move into the third and fourth scenarios. So here's what the setup is. Transaction performance. When I say transaction performance, this is not in terms of application performance management tools. We're not talking about transaction performance within a single process on a single machine. We're talking about distributed transactions across multiple systems, multiple code bases, and multiple machines, right? So this is a very tricky problem, and let me try to describe what this is going to do. So in Sumo Logic, we have certain sets of transactions that are very important to us. For example, when you as a customer go on site and you start a new search, that creates a big, highly distributed transaction in the Sumo Logic engine, and we live and die by the performance of these searches. We measure them maniacally. We want to make sure that we're providing the good experience to our end users, and we need to track our transactions across multiple services, frequently in different data centers, right? So what happens here is when you trigger a search on your UI, that search actually goes through and spiders through our infrastructure, uses different types of services, and then runs all of the things that you wanted it to run, and then brings that back to your UI. We need to track how long it takes for those hops to complete. So I'm going to run through a simplified scenario of that using some of our advanced operators. And in order to set that up, let me show you some sample lines that we're going to be looking at here, right? So the first line, this is a classic problem that companies have, is they have some sort of a line that signifies a transaction end that was written by one developer, and that developer, because there is no blueprint of how you do logging, has a timestamp and has some session ID that corresponds to that particular transaction. In our case, it will be a search transaction. And then you've got the transaction end, which essentially was written by a different developer who operates on a different system, and they have essentially chosen to write this key value pair very differently. So I can't actually really easily correlate on these two because I need to find both of these, their different values, and then once I have both of them, then I can sort of do a delta, and that'll tell me the duration. So I'm going to use our sessionize operator to do that. All right, so I'm going to now stop that sharing, and let's switch back to our demo. Okay. Let me see. Just 1 second here. Okay. All share. Can you guys see this? Is it on yet? Okay, excellent. All right, so we're back in our scenario. So what I'm going to do is I'm going to restart this scenario. We're going to switch back to a different, same infrastructure, different data set. Actually, I have a small starter query that is going to help me get to that without having to type too much. So here's what this is doing. This demonstrates another capability in the search language, which is, if you look at it up here, we've got something that we have the Boolean logic again. I'm looking for two types of log lines. One is the creating query, and the other one is defined by exiting search query. And then I'm going to use the metadata field here, service, to isolate to one of our modules. Basically, I'm going to just look at this particular module where we are logging the start and the end of the transactions after the transaction traverses all of these other systems that are involved in the transaction, right? And I'm going to also extract the message time from these transactions. So here, in milliseconds, as you can see, I've got a specific message time. I've actually chosen a particular time. I looked earlier before we started. Yesterday, we had a time when this development system, and because it's a development system, it's not very active, had a bunch of QA testing against it, which generated a bunch of interesting data that I'm going to analyze right now. Okay? So what I'm going to do now is I'm going to show you how you would actually connect the fact that, you know, when you look at down here, you've got things like creating query, which means that I'm going to look for creating existing query, log line. Let's see. So exiting search query, for example, is the log line that signifies that something is being finished here, right? And if I look here, there is a session ID, as I described it earlier, that looks like that. That is a session ID. Session is equal to something, right? And you know, if I go down and I look around for, so these are just the queries. Let's just go in here. Let's see. Yeah, all right. So I can't navigate to that one, but let me just go and type the query, and I'll show you what it looks like. So I can now do. And actually, instead of typing it, I'm just going to pull up the next step in here because it'll be quicker. We won't waste too much time. So here, what I'm showing here is I'm using a sessionize command. And the sessionize command actually is a command that helps us connect the dots across different types of log lines to actually create a session, create a transaction session that can then help you analyze those transactions. So if you look at the sessionize here, what it does, it says, look, I'm going to look for this particular pattern in one of your log lines. And that particular pattern comes from this creating query log line, which is the beginning of the query, right? And if I go down, I'll find that in here, it's called stream session ID. And if you look down here, that is the actual value that I'm trying to extract. And the sessionize will find it. And then it's going to also say, look, for all of the other log lines, it's going to look for the exiting search query. So in this particular case up here, there's the exiting search query log line. It's going to find what I showed you earlier. It's going to find this, and it's going to extract that, and it's called a session ID. The reason for that is so that I can find a log line and a session that match, right? So that created and finished are matched together, and then I can analyze them to figure out what is the duration of that. Okay, so the next thing here to do is actually, again, I will, let me go in and add extract some information. So what I can do, I'm going to do a trick here. I'm going to take a minimum of message time, which is the time of that the message was generating, as start, and I'm going to do a max of message time as end. I'm going to do that by session ID. Okay, so what is this doing? This is basically going to aggregate information, and I'll show you the output first, and then we'll analyze what it does. What this has actually done, it said, okay, now I've sessionized, I've created a transaction out of these simple log lines, and I now know that a session ID had a start time of this millisecond and an end time of this millisecond, and that's now starting to get me to the place where I can actually have a pretty good picture of the duration of these. Now, I need to do a little bit more. So I'm going to show you the new technique of actually using this data to create new fields. So now I have a start and end, but how do I get to the duration, right? That's a pretty straightforward thing to do. So if I wanted to get that, I can just basically, because I've now created these new fields, start and end, I can now just say, literally, let's do an absolute here. It's just to demonstrate another function. So we have a full support for, Scala math library in the product. So, a lot of these are documented. A lot of these can be found in the Scala math library. But ABS basically will return an absolute value of a function. So I'll say absolute, and I'll do end minus start, and I'm going to call that duration. Okay? So when I run this, what that's going to do now is going to take a delta between those starts and ends, and it's going to create this new field value here that's basically the field value for duration. Okay, so now I can look at that, and I've got a variety of queries that were executed here, and so what else can I do with that? So now I can get a bit more fancy, and I can say, hey, what I want to do is actually want to sum all of these, just to make it clear, sum duration by. Okay, and now we'll be able to very easily graph this information and see what's actually happening. So if I graph it, it will tell you that the transactions that have occurred in this particular time range, they have a variety of duration times. I'd probably be concerned about this one. It looks like it took about 10 seconds to complete, but many others completed in a much shorter amount of time. So hey, maybe I want to do another thing here, and I want to sort by duration, and that'll give me a better picture of what I just do. Oh no, field value under some. Okay. Okay, so this is basically the picture of the transactions that were executed that many individual systems have participated in. I was able to extract their IDs. I was able to sessionize on them and actually do operations to actually give me clarity around what transaction performance we've been hitting. So one of the other things that I want to show here is I ran this query just a little bit ago. And because we have a few more seconds, I want to show you another trick here. So what we've got in here is we actually, I'm using, again, mathematical operation to generate a histogram of transaction times for a full day of data, right? So this is, again, on the system that I'm running on right now. So I looked at the distribution of transaction performance times over the last 24 hours or 24 hours from midnight to midnight yesterday. And what this tells me is that we have a pretty good distribution picture in this dev system where our searches or our transactions here are actually occurring in these buckets. So it looks like majority of them are happening between, essentially 1 second to about 3 seconds. With some, spikes and dips in there, but bulk of this stuff happens very, very quickly. Obviously, that depends on the profile of the query that people are running, and then you've got a long tail of either more expensive queries or queries that have run into issues and things like that because of the development code. But basically, we can show you, we track this kind of metric very closely at Sumo Logic, and it's a very straightforward way to generate this kind of information by using a simple trick. So what I'm doing here, if you look at this, I'm using the floor function, and I'm dividing the duration by 100. Essentially, I'm fitting the transaction times into buckets of 100 milliseconds, right? So how many queries or transactions completed within 100 milliseconds, 200 milliseconds, 300 milliseconds? That's a very sort of a common way of measuring things. And then I'm basically creating a bucket and counting by that bucket. Essentially, this simple operation here will produce to me a histogram, a stack of information that shows me this metric. And I can tell you that we have, live dashboards monitoring this on our production system for our customers, 24/7. So that's the end of the actual, deep dive. I think we were actually able to cover. Let me stop this sharing of this and go back to our PowerPoint. We were able to cover most of the things that I wanted to cover. And hopefully you guys have questions. And a lot of the stuff you'll find documentation on in our online docs. and examples in our support system, Zendesk. So I guess you guys are not seeing this. Oh, there you go. So I'm going to stop here and open it up for Q&A if there are questions out there.
Great, Bruno. Thank you very much. And just as a reminder, if you do have questions for Bruno, please enter them into the Q&A dialog box that's in the WebEx panel in front of you. One of the questions that's come in, Bruno, is can Sumo Logic incorporate metadata as part of analyzing logs?
Yes, absolutely. So I showed very little bit of that by using a source category meta field that we have, but we frequently use that and our customers use it very, very heavily. So metadata, we have a lot of metadata that we store with each log message we collect. Metadata is as simple as, this is where the host where this message came from, or the file, or the tag that we arbitrarily decided to put on this metadata. But we also have, like I showed you earlier, message time is a metadata field that we stamp into each message. We've got a variety of other metadata fields that are available for analysis. But, it becomes very useful. We actually encourage our customers to heavily use the tagging methodology that we have in our product, which helps them further narrow down what they're looking for. I use the tag service to isolate the transaction logs, but I could have also used multiple of those within the search query, and those also support wildcards. So imagine that you're looking at a piece of production infrastructure that is Apache, and you've got Apache East, Apache West. You can look across all Apache by simply saying source category is equal to Apache star, right? So metadata is very important. We think that it will help, tremendously sort of in quickly narrowing down to what you're looking at.
Another question. Obviously, when you were going through the demo, the search demo, I think, we're certainly familiar with what log reduce is. Do you want to spend like 10 seconds talking about how log reduce can be used as part of the whole, the search function, and do you typically see customers using it right at the initial phase of troubleshooting, or, where would you use it in the context of a deep dive that you just showed?
Sure. So log reduce is probably going to be a whole other topic of one of these webinars coming up at some point. Not to pre-announce it, but I'm sure that we'll do a deeper dive on analytics and log reduce. But log reduce is basically, it can be very, very helpful on actually both front end and the back end of analysis. Log reduce, just for people who don't understand what that is, who haven't interacted with that term before, log reduce is our patented advanced analytics capability that leverages machine learning to really extract patterns out of data. So what it's frequently helpful on is, instead of, as you saw me at the beginning of this session, run a query for error or fail or exception and get 10,000 results back, in 650 pages, it's very hard to sort of sort through all of that and to understand what's actually going on. Log reduce is a tremendous help to that. So I could have just simply done log reduce on top of that data set, and what that would have done is it would have given me only the patterns that comprise that data set. So we would have found unique exceptions, unique errors, unique failures, and it would bubble up to you, a page or two of data instead of 650 pages of data. So it's very good at the front end to sort of reduce and comprehend. It's also very good at the back end. Once you sort of analyze the data, you can actually then use log reduce in a good state. Like, for example, let's say that we didn't have that spike in stream errors that we saw in my particular analysis, and let's say that we sort of saw something that's more smooth than was expected. Then you can use log reduce to actually to run a baseline and save a baseline of the behavior, and then use that baseline on an ongoing basis to compare the existing behavior of your application or infrastructure to the baseline, which was recorded when things were quote-unquote good, and then get alerted or get notified when things are shifting from that baseline, and when what's happening now is different than what's happening before. So, for example, the baseline analysis would have probably caught those stream exceptions that we were getting in the search that I was running earlier. So that's the gist of log reduce, and we'll probably do a deeper dive into that at some point in the future.
Great. Another question that just came in is, can you join transaction data with back office profile data.
Absolutely, yes. So I didn't get to that. That was going to be too much for today, but we have operators in the product that help you do lookups and joins. So we can join, we can essentially, one of the examples that I could have shown here is how I find which user actually, which organization or customer of ours triggered the transactions I was measuring performance on. So that would have helped me, for example, monitor how is the performance of our transactions distributed across our customers, right? And be able to tell me if I'm at risk of violating an SLA for a particular customer, right? And what I would do for that is I would actually extract from our CRM system, which is what we do. We extract from our CRM system. We use Salesforce.com, the names of organizations of our customers, and we merge that data with Sumo Logic log data, and we can actually look up customer organization names, even usernames from that table, and join that with a query, and then you get a lot more context in your data. So yes, we do that all the time. Many of our customers do that as well using our lookup operators.
Great. Well, I think we have gone through all the questions that have been asked. Once again, as a reminder, we have recorded today's webinar. We will make it available shortly after we finish the recording and finish all the cleanup. And if you do have questions, please don't hesitate to ping us. We do have, oh, actually, there's one other question that just popped in. That's around collaboration. So I'm going to guess here, can you share queries, and if so, how do you do so?
Yes. Right. So every query, every dashboard in Sumo Logic can be shared within the organization. So typically what we see is most of our customers have experts in particular areas, and then they've got teams of people who need to sort of, round the clock monitor infrastructure and things like that. What we can do is you can, with a single click of a button, you can share a query or share a dashboard with your entire team, and everybody gets to use it and run it. So in terms of what we also support is we have a full role-based access control system in the product. So let's imagine a scenario where you have an administrator who shares a query to end users, and then that query is run by end users with lower levels of privileges. You actually can configure it in such a way where you provide not only the shared query, but you can also restrict what other users who run that query can see. So basically, you can get very granular in the control of how you collaborate and what you share with the sharing and role-based access control features.
Great. Okay, so if there are no more questions, I'll hesitate this time because I know another question might just pop up. But if people don't have any more questions, I just want to thank everybody for taking the time out of a busy day to join us, and we will see you at the next webinar. Thank you very much.
Thank you.